up 5 times, and we're doing this up 3 times. So what's 4 times 4 times 4 times 4 times 4? Take it go.
4 times 4 times 4 times
4. Or 4 to the 5th.
1,000.
Close.
1,000 what? 20. Okay. And 4 times 4 times 4?
64.
Okay, now let's simplify this graph.
16.
Okay, we were taking 16, and I want to write it as 4 to the something equals 16. 4 to the what is just 16. 4 to the second. 4 squared is 16. Okay, how can I relate this to that? One mouse right there on the way there. Get up there. How can I relate 4 squared from 4 squared? Yeah, 5 minus 3. So x squared on the top minus x squared on the bottom gives us our whole answer. So this is really just 4 squared because we get 16. Or you can think about, well, I know that these two are going to cancel each other out, and these are going to cancel each other out, and these are going to cancel each other out, and we're left with just 4 times 4, which is 2. That's what all works. Okay, so we can do the same thing over here. We can say, well, these cancel out, and these cancel out, and we're left with 3 over 4. Which is the same as if we take the top times the bottom to get 4. Okay, simple enough, right? So to divide 2 powers and have the same base, subtract the exponents. And always remember to go top minus bottom. Don't go backwards.
Okay. Will that, like the crossing out, will that only work?
Yes, but you wouldn't want to do that all the time when you get really big exponents. It gets messy. But then it would be good way to double check your answer if you're not too sure on this. Okay, example 1 is simplify. And it says assume that A and B are not equal to 0. Why do they have to put this in there?
Because you can't do 0 and 0.
Okay.
Can't divide by 0 on the bottom.
Yeah, because the big yellow poster says that shall not divide by 0. You cannot put a 0 on the bottom. Can I give my example of a cookie jar of why we can't divide by 0? Yes, no, maybe? Okay, like if I had, let's say I have a cookie jar, and I've got 10 cookies in the cookie jar, and I take 2 of them. I can take 2 out of 10, right? Okay, let's say that I have 10 cookies in the cookie jar. Can I take 0 out of 10?
Yes.
Yeah, okay. Let's say I have no cookies in the cookie jar. Can I take 2 out of nothing? No, you can't take 2 out of nothing. Okay? Because the bottom number tells you how many total there are. Top is telling you how many you're taking out. So I cannot take 2 out of nothing. That's why you can't divide by 0.
Can you,
I can put 0 on the top, so I can take nothing out of something. But I can't take something out of nothing.
unless you take nothing off. 0 out of 0.
No, you can't take that out. That still doesn't work either. Okay, so they're saying again, maybe aren't equal to 0 because if they were down here, they would have a 0 bottom, which can't happen. So they just say, assume that it's not true. Alright, so going anyway, back to this. If I'm looking at this A in the bottom, what's its exponent? 1. And since I've got an A at the top and an A in the bottom, what are we going to do with exponents? Great, so we have A to the 4th. Good, because 8 minus 3 is 5. Easy peasy, right? Yeah. Alright, now let's look for another pattern. They've taken this. It's the same exact thing as what we were doing yesterday when we were saying, okay, if we had a fraction to a power. I say you can think about it as 2 to the 3rd over 5 to the 3rd and distribute that power top and bottom. They're showing it in a different way. They're just saying, okay, this means take the fraction times itself 3 times, which means take 2 times, or times itself 3 times and 5 times itself 3 times, which is the same thing as what we did yesterday. So this is nothing new. Alright, so to find the power of a quotient, by the power of the numerator and the power of the denominator. In other words, if you have parentheses around something with the exponent outside, always remember to distribute through. In this case, distribute through on top and bottom in this fraction.
So then, okay, then I go ahead and distribute.
Okay. Alright, so what are we going to do?
Distribute.
So we're going to distribute everything, right? So we're going to have 2 to the 4th and p squared to the 4th and 3 to the 4th.
When it isn't, then all I was gonna say is, isn't it 3 squared to the 4th? Because you have to move your top down, that's what you said.
Say that again?
Well, like up above and just like in that thing you just did where it says look for a pattern, and we have like 2/5 to the 3rd, and then you move 2/5, you move the 3rd down, so it's your feelings. Oh no, it's that's that. Oh yeah.
Okay. Good. This is why I'm calling you there.
Okay, sorry, that's kind of
Alright, so let's simplify. What's 2 to the 4th?
There's 16.
16. And then what happens to 13?
4 times 2.
Good. 4 times 2, which would be 8. Yep. And then, I don't remember what 3 to the 4 was. Is it anymore? That's not 3. No, 3 to the 3rd is 27. And then I would look and see, can I simplify? If I just cover on this p, can I simplify this fraction? 16 over 81? Right. Because, like, I know 16 can be divided by 4, but 81 cannot be. 81 can be divided by 3, but 16 cannot be, so that's as far as that goes. Any questions so far on things? Alright. So the next. It asks us, why is 2 to the 0 is equal to 1? Once you're trying to calculate, you're trying to take something to the 0 out.
It's just 0.
Is it 0?
1.
You get 1. Type in a negative to 0. What do you get? Negative 1. Okay, so, this is equal to 1. What happens? Okay, so they're showing us in 2 different methods of why this happens. Okay, method number 1, they're saying, okay, well, when we have something divided by something, the bases are the same, they just told us we had to subtract the exponents, right? Okay, so in this case they said, well, x to the 4 divided by 2 to the 4, that means 2 to the 4 minus 4, which is really what? 2 to the, or 4 to the, 2 to the 0. Can't write. 2 to the 0. Okay, well, what happens when I take something divided by itself? 1. Because something divided by itself is 1, so I know that 1 has to equal to the 0. So we just get 1 equals 1. You follow me?
No.
No? Okay, what do we do? Okay, like we said, James, we have something divided by itself and we have different exponents we subtract, right? So exponent minus exponent. 4 minus 4 is
0.
0. Well, we said something divided by itself always has to be 1. Therefore, 1 has to equal 2 to the 0. So 2 to the 0 has to be 1.
Okay.
Does that make sense?
Fine.
Okay, or we can look over here. They said, well, we could also write it out because 2 to the 4th is 2 times 2 times 2 times 2, and 2 times 2 times 2 times 2, which, like we did with the whole crossing out thing, we said, well, these are going to cancel, 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 so we're just going to end up with 1. Right? Or we can think something divided by itself is 1. Does this help? All right. So anything to the 0 power is 1. Alright, example 3 says simplify each expression and assume that x and y are not equal to 0. This one looks really nasty. What can we do?
But it's 1.
But it's 1. Whole thing?
Yeah.
Yep. Whole thing is 1. if everything is to 0. So circle, right? Okay, how about this one? Is everything equal to 1?
No, 1/2.
Right, because we have t to the third over t, because x to the 0 is just 1. So we don't really need to write it in there. And then, what do we do with exponents? Yeah, subtract, right? Because remember how I said yesterday, when you multiply, that means we add exponents. Now when we divide, we subtract exponents. Just like that, one step below it. Okay? So 3 minus this is understood 1, so it's really t squared.
So whenever you have a thing to the 0, just get rid of it since it doesn't matter since it doesn't.
Because it's just going to be times by 1, so it's just gone. Okay, anything okay with that?
Yeah, the 0 has to be on the outside of everything.
Right. 0 has to be outside to make everything 1. It's just with one thing, that only double makes it.
This is how the same thing go.
Yes. Have fun. All right. Yes.
Look at the but consider when it's not really a winning, is it? Well,
You are.
you tease them.
Yeah.
Win for it.
Where's he on?
This whole thing.
I think we're gonna stop there because we don't have a whole lot of time.
We have like 7 minutes.
We have 30
Minutes.
minutes. 30.
You think we can get through most of it? Maybe? Let's try. Okay, so that's what happens when we have a negative exponent. Well, they're giving us an example here, and again, remember we subtract top minus bottom exponent. So what's 2 minus 5?
-3.
So we have 8 to the negative 3. Alright? Yeah, we can have negative exponents. Okay, so in this case, if I was looking here, and if I go 2 minus 5, I get 3. That means since it's a negative, it ends up to be in the bottom. So I got 1 over 8 to the positive 3. When I take it and move it to the bottom, it changes its sign. If I started off with 1 over, just making something up, 5 to the negative 2, or 3, I guess we're 3. That means move it to the top. So in this case, it would be equal to 5 to the positive 3 if we wanted to convert the negative.
So if you have a question like that, you just just change it.
Right. Negative exponent just means it's at the bottom, move it to the top, make it a positive. If it's in the top and it's a negative exponent, then you move it to the bottom, make it positive. It just takes, move it from one to the other.
Is there any examples on this?
Oh yeah, we'll just start like this. Okay, here's another example of why this happens. Okay, so they said, well, we can take this and say this is 8 squared, so 8 times 8. And 8 to the 5th is 8 times itself 5 times, right? So we can do cancel, cancel. We're left with just 1 at the top. So this is the same as 1 over 8 to the 3rd. Same as what we had over here. 8 to the 3rd in the bottom. Okay? So it's okay, I promise. I see some scared faces there. It's fine. I promise. Okay, so for any non-zero number, and any integer in, if a is to the negative n is the reciprocal of a to the n. In other words, if it's the top, make it the bottom put it to the top. And it says an expression is not considered simplified if the expression contains a negative exponent. So hopefully there's another example will help you out here. Okay, simplify and assume that no denominator equals 0. First, I'm looking to see if there is anything that is the same, anything that's similar that we can combine. No. Okay, so we have to look at our negative exponents. Is b to the negative 3, it's in the top, it means move it to the bottom. So I'm going to put b to the positive 3 in the bottom. Whenever I move it from the top to the bottom, it changes its sign.
And then you do the -5, so make sure you move that to the top.
How about c squared, or is he going to stay?
Stay the same.
He's going to stay on the top.
What's that?
No, that's it. Alright, let's look at b. First of all, let's see, is there anything that we can simplify C5, or anything that's got the same base that we can combine?
A.
Standby for announcements. High school is now dismissed for chapel. High school is free from home shares in chapel today.
So don't the.
I'm assuming that means a little.
It's in high school.
It's in high school. Oh, let's see where you finish this one. We'll go with that.
So the B's are the same exponents.
Oh, there's the door.
Alright, so yeah, B's cancel out, right? B to the 7 over B to the 7 is gone. How about if I have a to the negative 4 and a squared? I'm still subtracting, right? Top minus bottom. So what's negative 4 minus 2? A to the negative 6.
That's
Is
on.
that still on
That's still on top and right.
That's still in the top.
And then
Where did you get that?
Where do I get one from?
the, she's combining the A's.
The B's cancel out, and then A to the negative 4.
Yeah, but how do you get negative 6?
Okay, rather than thinking about it this way,
Oh, you're saying, oh, I get it.
because we're subtracting, or you can think, okay, this a tells me move it to the bottom, right?
Negative 6, right?
So we have a to the 4th and a squared is still in the bottom, right? So it'd be a to the 6th in the bottom. Following?
Or A to the negative 6 in the top.
So you can just
What
put
would
it to
be
the bottom
A's?
separate.
But then you move to the 20 with negative 3.
Okay, if negative 3 and 21. Negative 3, we're going to move it to the bottom.
Yeah.
Is it the negative exponent?
No, it's not a negative exponent.
No, it's not a negative exponent.
So
So just 3 and 21, can I simplify the fraction?
Yeah.
Yeah.
You do,
Negative 1 over 7.
1 over 7. Yep. Okay, how about this c? We got this c. What do we do next?
A's in the one.
Nope.
Oh, wait, no, yes, I think that's one.
So move it to the top.
No.
So negative 1 C5 over 7 A6.
Yep.
Okay.
Yeah, it's a little confusing.
I'm